driving innovation through natural user interfaces. So just to give a quick overview of what I'm going to cover today, first going to talk a little bit about my professional journey, how I ended up where I am today. Then I'm going to cover some projects that led me along this journey that I think might be relevant to this audience. Then I'm going to dive into the core of this presentation about how to build XR experiences with natural user interfaces. And then I'm going to cover two particular projects that I worked on that really showcase how natural user interfaces brought them to life and was shown to the general public. Like it was mentioned, I will have Q&A at the end, but questions are encouraged throughout, so feel free to drop them in chat, and we'll try to get to them as we go. All right, so just a quick background on my professional journey. So I started off by getting a bachelor's of science in both computer science and psychology at Stony Brook University. Shortly after that, I was lucky enough to join a startup called Actor Machine, where I studied under Ken Perlin, who's one of the fathers of graphics, who's known for both Perlin Noise and an Academy Award for Tron, the old 1982 version. And while I was there, I was working on procedural animation systems. Now, I learned a lot of really cool things at that startup, but the most important thing was really I learned that anything is possible with computing. So if you can kind of dream something to be made, you can do it. And it's a philosophy that I encourage everyone to really take forward in this field of just, envision it and go for it because anything's possible. Following that, I went to Northeastern University in Northeastern and got my PhD in computer science, focusing on human-computer interactions under Professor Timothy Bickmore. While I was there, I also was lucky enough to work at the Relational Agents Group, where I developed embodied conversational agents. And I'll talk about that again in a few more slides. Following that, I moved off to the West Coast and joined a small startup at the time called Ultrahaptics, where I was the first engineer in their US office. Now, over the course of the years, Ultrahaptics eventually became Ultraleap after acquiring Leap Motion. So for those of you familiar with this hand tracking device, it'd be this. And likewise, my career evolved where I became the principal engineer and the head of the US customer applications team. Now, I had a lot of responsibilities in this role, ranging from developing trade show demos to building prototypes to customers to showcase how Ultraleap's natural user interface technology could be used to create immersive XR experiences. Additionally, I was lucky enough to have the opportunity to conduct training sessions at hackathons and Fortune 500 companies on how to utilize this hand tracking and haptics technology. So I was out at events like the MIT Hackathon out there in Boston, which I highly encourage people to go and visit and try to attend, Stanford XR event, among a bunch of others. So with kind of the backdrop out of the way, I want to talk about a few projects that kind of led me along this journey. And they're really going to cover three different areas. The first is XR, which is obviously relevant to everyone here today. The second is conversational agents. So this is back on the work that I did at Northeastern on those embodied conversational agents. And then finally, natural user interfaces, which is what a lot of my work has been related to. So to kind of start with the oldest first. So back in 2017, I was at Northeastern. I was doing my PhD thesis, and I was building these lovely characters right here. So this is an embodied conversational agent. It's an animated computer character that tries to emulate face-to-face conversation. Yep.
I'm sorry, but actually your slides are not advancing.
Oh, really? Oh.
We're still seeing the title slide.
That is
now
weird.
We see it.
Now, okay.
Okay.
Give me 1 second to try to fix that. Let's see if I can do this here. Get that working. All right, let's see. All right, hopefully people saw some of this now.
Okay, yeah.
Cool. All right, awesome. So I was working on these embodied conversational agents. These were animated computer characters that emulate face-to-face conversation. And what I would do here is these were often deployed in healthcare settings. So into people's homes for more kind of serious medical rehab. In the case of my thesis, for example, this was focusing on depression counseling. So, helping people with depression from the comfort of their home with these animated computer characters. Now, while I was there, this was also back at the time where XR was starting to kick off.
I'm sorry, Lazlo, again with the slides. Now there's like a box kind of
okay.
covering.
Right. Let's see if I can fix this a little bit more. The joys of Zoom technology. All right, let's see if that works any better. All right, can you see that?
Yeah, yeah.
Okay, good. Okay. as it advanced a few slides. Just go back here. Okay. Um, like I said, back in 2017, this was kind of the early stages of XR technology. So the Oculus DK1 was just coming out. This is the time when the HoloLens was just coming out. And it was a really interesting medium that I thought might be cool to explore. So what I did is I took those embodied conversational agents that I was working on, I'd been developing in Unity, ported it over to the HoloLens, and looked at how we could actually interact with them in XR. So this is actually a recording that I took at Northeastern. And I added speech-to-text capabilities to the embodied conversational agents. And then I was able to have a conversation to it while it was floating just in the air above me, as if it was a real person that I was talking back and forth with. And I thought this was incredibly interesting to kind of pursue. I thought this is a really cool technology and how else could be used and what else to do. Now, I didn't really know much about XR at the time. Again, this was when it was kind of the early stages of it. So I went looking for something that I could hopefully expand my skill set in, and I was lucky enough to find a job at Ultrahaptics. So when I joined Ultrahaptics, they are, and still to this day, the world's leaders in natural user interface technology. So they focus on specifically hand tracking and midair haptics technology. When I first worked there, I learned firsthand how to utilize these technologies to create really immersive XR experiences. Now, it's important to note that back in 2018, when I joined, natural user interfaces weren't really common in XR. Almost every interaction you did on something like, an Oculus DK1 or an HTC Vive or whatever device you had back then was all based on controllers. So there wasn't really any hand tracking in it. There was no eye tracking. There was no, speech capability, stuff like that. So a lot of it was just very kind of, simple in that sense. Now, through the opportunity of working at Ultrahaptics, I learned a lot about how to utilize these technologies, but more importantly, because it wasn't present in the marketplace, we also had to learn why people should use this technology. And the reason commonly came down to barrier of entry and the level of immersion which this technology provides. And I'm going to go into that a little bit more detail later on. Now, natural user interfaces are obviously much more common now. If we look at like the Quest or the Apple Vision Pro, they're kind of the prominent feature of it. I mean, Apple Vision Pro literally has no controllers. It is only eye tracking and hand tracking, and it's the core technology kind of built around this whole thing. So like I said, worked there for a while, was able to build immersive showcases, trade shows to customers, working closely with them, do all kinds of stuff. So I'm going to highlight a few of these projects now. So the first one was actually one of the largest ones I had the opportunity to work on, called Crystal Cave. I made this back in 2019. And it was a 2-player walk-around VR experience that took place in a 20-foot by 10-foot walk-around space. The point of this project was to try to capture the location-based entertainment market, which is kind of like escape rooms in VR. So if you've ever done experiences like The Void or Sandbox VR, it's very similar to that. And at that time, they weren't really using Ultrahaptics technology. So we wanted to try to find a way to convince people to do it through the showcase. Now, this demo, I worked over the course of a few months, developed it and presented it at numerous trade shows, ranging from CES to IAAPA to AWE. And thousands of people actually ran through this in a completely unguided experience where we just put the headset on them and let them go. And it really showcased how intuitive these experiences could be when you start incorporating this technology by adding hand tracking and stuff like that. All of a sudden, you remove that barrier of entry where you don't have to give tutorials on how to interact with things. Likewise, it also really showcased the importance of multi-sensory interactions. So particularly in this experience, there was one spot where there was a station with fire, and people would walk over to it, put their hand over it, and they would feel some haptic sensation on their hands. They would hear the sounds like the fire sparkling. They would see the visuals of the fire, and they would go through the experience. They'd often come out at the end. They would look at me and they'd say, "That was a really cool experience, but I have one question." And I'd be like, "Yeah." And they'd be, "How did you make my hand warm?" To which I would reply, "I actually didn't make your hand warm. It was your brain that made your hand warm." So it really showcases like if you utilize all these senses of a person, they can really add up to making these truly immersive experiences that, are beyond what even you're able to create yourself. Next up, kind of going on the outside of headset realm in natural user interfaces, fast forward a little to 2021, when we were in the height of COVID, and companies were looking at how we can incorporate natural user interfaces into interacting things in the person's home. So the idea for this is imagine the smart home of the future, where let's say you have projection mapping and hand tracking technology, and you're allowed to control your home from pretty much anywhere in your house. So if you imagine I'm walking around, I'm looking at like a table, and I reach my hand out, and all of a sudden I have an interface in front of me that I can start playing with to control whatever I need to. This video is being showcased by my colleague right here, where they're interacting with this technology through iPad-style interactions. So things like swipes and expands and stuff like that, where you're able to control various elements of your house, like temperature and lights and social media, whatnot, to really show that you can really make a fully immersive experience just kind of anywhere, and it doesn't need to be confined to the headset. And it's definitely something that I've seen time and time again, whereas new technologies come out, so things like 3D displays, for example, natural user interfaces are more and more important to these technologies. I mean, if you ever see someone looking at like a looking glass, for example, or a Leia screen, one of the first things they'll do is they'll reach into that screen and try to grab something, because there's this 3D element that you really have to move beyond the keyboard and mouse to actually be able to interact with. So take a pause for a second if there's any questions on kind of my professional journey, and then otherwise I will jump into the main section. Okay.
No questions so far.
Okay, cool. Alrighty, so let's jump to the
Oh wait,
main.
we have
Oh,
one
yep,
question
yep,
from Carmisha.
Yes. Hey, can you hear me? It's a little noisy. Can you hear me
yep,
okay?
Yeah.
yep, absolutely, yep.
Okay. Thank you so much for this presentation. My name is Carmisha. I owned an escape room in Monterey, California. So I actually went up to Ultra Haptics and I got to play the Crystal Cave. I think this guy,
Awesome.
Harry, showed me around, and
Yes,
Chris,
yes.
one of your co-developers. Yeah. So I was very much interested in that for escape rooms, but it just turned out that the technology at that time, which was 2019, was really far, I think, not just accessible to a small business owner like myself. So I was wondering, we can talk about that part later, but I was just wondering, did that game ever make it into an escape room or a location-based place beyond a conference?
So that exact experience did not, but without naming the names of who was involved, the technology did get adopted by a large location-based entertainment company, and they spent over $100,000 buying stuff for it. So stuff will come down in the future. I just can't publicly talk about it yet.
Got it. Okay, thank you.
Cool. All righty. Great question. Thanks. Cool. So with that, I will jump into, I guess, the main part of the talk on building XR experiences with natural user interfaces. So to start off with, I really want to highlight that different tools are needed for different occasions. I'm not going to say the controller is always better than the natural user interface, or the natural user interface is always better than the controller. They both really have their pros and cons. So controllers, for example, have really reliable interactions. They have very high precision. You can move them exactly where you want them to go, press buttons to do exactly what you want them to do. And it's really robust to the environment. A lot of problems with natural user interfaces come when you start occluding it or moving it in places where it doesn't have line of sight. So for example, if I'm doing hand tracking and I move my hands away from the field of view of the camera itself, obviously it won't work. Likewise, if I'm obscuring it, you might run into issues there. So that's where controllers kind of have some advantages. Additionally, they have haptic feedback, which means when I do something, I can get some kind of confirmation back that I've done it. And then also I have the ability to do locomotion through those thumbsticks, which is something that's really kind of an unsolved issue in natural user interfaces still to this day. On the flip side, though, natural user interfaces are much more immersive. They have a much larger interaction space, so more possible inputs where you can, do various different things in a huge variety of ways compared to just hitting the controller in a specific spot. And then also it has a much lower barrier of entry, allowing for much more intuitive interactions. So, see a question there?
For natural user interfaces, is it possible to use like gestures to like mimic joystick movement? Like if someone like gestures their hand in a certain direction, and a person moves there, does that count as a natural user interface, or is that still like something different?
I would, and I'm actually going to cover this in a second, where I talk a little bit of the difference between like gestures and that, because often people think exactly that, where like a natural user interface is just like doing a gesture. And I really want people to kind of think beyond that. So I'll actually get to that in 1 second to try to answer that a little further. Okay. All right. So just kind of breaking down on one level. So understanding kind of input space. So like I mentioned, controllers versus natural user interfaces have a large variety here, where you're trading off the precision versus what you can do. If you think of your typical controller, it has probably 6 buttons on it, like 2 face buttons, some triggers, and joysticks. Whereas if I just look at a single hand that's being tracked, that's 27 joints. And you're thinking of the relation of every single joint in relation to each other. And then to make it even more complex, you have 2 hands. So then all the joints in relation to each other. So there's this really infinite space that you can play with in terms of what you ask people to do and how people interact with it. Now, on that gesture front, exactly kind of what I was saying, a lot of people think natural user interfaces, they think gesture. And the problem is that gestures are often really complex and require a lot of training. So if I take this example, this is the bloom gesture that was the default in the HoloLens. And it was this complex gesture where you had to, pinch in a right way and then release. And if you've ever tried to use like the HoloLens 1, for example, I'm sure you've had the issue where like you do this 3 times in a row to actually get it working, or you have to train someone externally on how to do it. Now, when I'm talking about natural user interfaces, I'm talking more about interactions like this, much more free-form, intuitive interactions where there's like infinite possibilities of how you actually do it. In this case, someone is generating a cube in front of them, and then the way they pick it up, they can really grab it at any point in that cube. They can grab it with any different myriad of gestures, whether it be a pinch, a grab, using 2 hands to lift it up and move it, whatever it may be, making the software robust enough where you can just do whatever you want to actually get it working. Okay. Now, like I said, there's a lot of thought when people go from controllers to natural user interfaces. They don't really think about it in the full picture. So often people will, see a talk like this and say, awesome, I'm going to grab, a hand tracking device, stick it on the front of my device, swap out all my controller inputs with hand tracking, and then it's going to be awesome. And the problem is, if you do that, you're actually going to create a really, really poor VR experience. Natural user interfaces really need to be utilized to their full extent to make them better than controllers. Otherwise, you're just emulating with a device that's just less precise in general. So I'm going to go a little bit into how you actually make those experiences much more intuitive and natural feeling. So the first step is you have to have interactivity at every single step along your journey. This can mean utilizing other things like sound and visual feedback to showcase the interactivity that you're doing with your natural user interface. So if we look at this one on the left, for example, where you're knocking over those blocks, what happens is as you move your hand close to it, you'll see the blocks highlight and color to indicate that you're actually close to the object that you're intending to work with. Likewise, there would be sound accompanying this, where you might hear the blocks knocking over, or different colors as you associate different actions with them. And then as you move your hand away, likewise, it will fade off to know that you are no longer interacting with it. Same thing on the picture to the right, where you see the orb right there. As the person reaches out towards that orb, it changes color to indicate they're actually able to grab it at that point. Once they grab it, it changes to yet another color, indicate they're actually doing the interaction they want to do. And then it guides them along the way to kind of showcase this is exactly what you're doing the right way. If I were to do the same thing with controllers, because of the way controllers are built, you could just use haptic feedback or something like that to do this in a much simpler way, because you have the exact precision needed to know what's going on. Here, you're kind of supplementing that a little bit. Likewise, it's really important to show through example. So if there's things you can show within the scene of how to do an action, it's much more powerful than show a long tutorial, because like I mentioned, natural user interfaces have these huge possibilities of the ways you can do it. And you might be limiting someone based on something that's not natural for them to actually do. So if I tell someone to grab something in a very specific way, it might not be the way they normally do it. I've seen people, pinch with different fingers, for example, when they pick something up, or, do different, gesture combination. If I ask them to do like 1, 2, 3, depending on the culture, they might do like 1, 2, 3 with their fingers in a different order instead. So if there's a way to showcase it in the scene itself, it becomes much more powerful. The one on the left is a great example of this, where we had a little agent in our scene to tell someone to do a gesture, a thumbs up in this case, to move on. And this demo, while it was written in English, was actually given to plenty of people who did not understand English whatsoever. But because of the mimicry given by the agent, they are able to follow on relatively easily by seeing the agent does something, I do something similar. That's how I follow along this. On the right is a different example where we can use this, what I would call a ghost hand, to indicate where you can interact with things within your experience. So for example, if you put your hand out and reach in this specific area, it would advance the interaction. Likewise, it might show something of like where exactly you should grab something, how exactly you should move something to showcase how it moves along naturally in this way. Multimodal interfaces are also something I kind of want to bring up here, where each natural user interface really has its own strengths and weaknesses. So in this case, for example, this was some work I did alongside Toby, where we were looking at both eye tracking and hand tracking and the combination of the two of them. Now, if I look at these individually on their own, eye tracking has really, really good precision. You can look at exactly what you want in a scene and get a pinpoint accuracy of that. But the problem is it's really hard to control something with that. You'd either have to stare at it for a long time, which can cause eye fatigue or just not really good because your eyes will wander around. Or you'll have to do something weird like blink or do some other action alongside of it, which kind of breaks the immersion factor. On the flip side, while hand tracking has this kind of infinite area of control, it is much less precise in what you do. And a great example of this is like throwing a ball in VR. If you're throwing it, it's much harder to know the exact point of releasing it because you don't actually have something physical in your hand. So as you do this motion, it's hard to know exactly when the person intended to drop it or not, which will often cause it to drop prematurely or too late. By combining the two of these, we can actually kind of utilize both their strengths together to make really immersive experiences. So in this case, eye tracking was actually used to look at the various cubes in the scene. And then when you made a throw gesture, it didn't actually matter on how you did the throw. The eye tracking would auto-correct it so that it would automatically hit the right spot that you were looking at, which made it feel like you had perfect aim no matter how you were doing something. So last little part I want to talk about is really simplifying complexity by making interactions physical. So I want people to imagine that there was no visuals in a VR scene for a second and you're just looking at a person from the outside doing it. If I had someone doing the interaction on the left, for example, where they're picking something up and pouring it, what I'm actually asking them to do is a lot of really complex gestures in a row. I'm telling them to pinch at a specific spot, move along a trajectory, hold their hand upside down for a certain amount of time, and then do the reverse trajectory and let go in order to complete this. Now, if I were to ask your average person to do this exact gesture, as I said, in the exact time and exact order, they probably wouldn't be able to do it because I'm sure I wouldn't be able to do it either. But if I put physicality to it within the scene, all of a sudden I can rely on the user's innate knowledge of how the world works. So in this case, I'm telling them to pick up a milk jug, which people know how to do. They just go and grab it and go and pour it. And that way I don't have to teach them, this is how you pour, this is how you grab something, this is how long you have to hold it. There's all visual cues kind of giving them exactly how this should be done. Likewise, if we look at the picture on the right, here you're doing, again, a lot of complex interactions. You're doing micro adjustments of different cubes. You're picking stuff up and dropping it in exact spots. And all of this, because of the physical nature behind it of how it's being portrayed, allows you to have them do really complex tasks without any instructions whatsoever. So I'll pause again just quickly if there's any questions. Otherwise, I will kind of dig into some examples of how this was actually used out in the field.
Yeah, I have a quick question for you, Lazlo.
Yep.
Yeah. Hey, I was just wondering, is there any technology? These are really cool examples of how, like, the differences between natural user interfaces with controllers and ways that you can augment or enhance, like, the natural user interface. Are there any kind of blends of those, though, where maybe you have like a bracelet or a ring or something that helps increase precision and locomotion, but still have like that natural interface?
Yeah, absolutely. So I've seen this done in a bunch of different ways. Often there's like physical objects that people will accompany with it. So I've had an example where we did fiducial markers on actual like cups themselves. So if you imagine a cup like this, you had a fiducial marker on it. And so that way that was being tracked much more robustly and then regardless of what was happening on the hand tracking. So no matter what you were doing with it, you'd be able to interact within the space. This was always solid. And also it allowed for actual extra haptic feedback because you knew exactly what you were grabbing. And then likewise, the hand tracking was just used to supplement the interaction. So like I'd be able to do it, put it down, have my hands free to do some stuff, go back to it, and then kind of continue this interaction. Other things like bracelets, like you mentioned, and other augmenting devices. There's like multi-systems that I've seen people use with like the combination of a Connect plus a Leap plus other things all together to really increase that precision level to help it out. So yeah, absolutely.
Cool, thank you.
Yep. All righty. There's no more questions there. I will jump on to talk about this in action. All right. So I want to kind of highlight two projects that I worked on where it really showcases why natural user interfaces are great. The first one is this barista training project that I worked on back at Ultraleap in 2021 and focuses on VR and hand tracking. So just to set the stage a little bit, a lot of companies at this time were looking at training in VR, and they still are to this day. And they were very curious about using it to replace the traditional training methods that they had. Often it was like paper or just YouTube videos, and they saw, VR training was starting to take leverage in other industries. Sports, for example, it's used a lot now. And so they're wondering how they can incorporate it into their own work. The problem is that a lot of them would do these really early pilots where, like I said, they'd stick someone in with controllers, let them go into an environment, and novice users would be incredibly overwhelmed by the complex controls. They would end up like, handing the controllers, spinning around in circles, staring at the ceiling, not knowing what to do, and just getting frustrated and unhappy with the experience. Additionally, because of the use of controllers, it wasn't really realistic to the actual interactions they were doing in the real world. So if I told someone to, bread a chicken, for example, a controller going trigger, 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 trigger isn't quite the same thing as using your hands to, actually be able to feel what exactly to do, how to hold it, how long to lift it up and move it, stuff like that. So you weren't really making that muscle memory at the same time. So it was brought to us and said, okay, how can you use the natural user interface technology that's available at companies like Ultraleap to up-level that experience even further? So, again, kind of looking at the problems at hand, really we were dealing with the intimidation of VR. So existing training material was something like this. So it was a document where maybe if you're lucky, there's a few steps of what to do. You fill the coffee cup, you move it over here, you clean this nozzle, whatever it may be. Or there might be like a YouTube video showing someone how they did it. And someone would watch this a few times, go into the store, and then it was like, good luck, now do it in person. And you're actually wasting real life money and time because you're actually doing this, on the real equipment compared to the comfort of your own home. And additionally, when they were trying it in these VR settings, they found that the users were very overwhelmed by the complex controllers and all the instructions that were kind of being bombarded at them. So, you'd put them in a virtual room, you'd say, okay, hit this trigger button, hit the A button, do this, do that. And they were just like lifting up the headset, looking down. I don't know what to do. This doesn't seem to match what I would actually be doing. I'm very lost. So as you'd guess, the solution was natural interactions. By removing controllers, we had the users rely on the tools that they're most familiar with, which is their hands, and their innate knowledge of the world around them, which meant we didn't really need tutorials or instructions throughout this process. So in this example, I'm telling someone to pick up a cup, place it in a specific spot, and press some buttons. Nowhere in this entire interaction, and I'll show the full interaction in a few minutes, do I ever give instructions on how to pick up a cup, how to press a button, do anything like that. Yet thousands and thousands of people were able to go through this demo across trade shows, at various, companies, at internal events, whatever it may be, without a single instruction needed from an outside person because it was all relying on their innate knowledge of the world. People have been using their hands since they were a child. They knew how to pick up stuff and use stuff. By leveraging that knowledge, then all of a sudden become a very intuitive interaction. Now, I do want to put a slight warning here that along our course of doing this, we did find there is kind of a valley between realism and usability. When we were first developing this technology, what we were doing is we were trying to be as physically accurate as possible. And what I mean by that is if I was picking up a cup, for example, and I would take my hand and I would hold it, I was actually holding it based on the amount of pressure provided by my virtual hand on the virtual cup. Now, this sounds really cool in practice, but the problem was that because you don't have haptic feedback from what you're holding, you didn't know exactly how much you should be pushing it in and out. And because of that, what would often happen is we do this exact scenario in kind of the early test versions of it. We'd have someone pick up a cup, they'd hold it for a second, and then they'd accidentally drop it because they would relax their hand a little bit because they didn't know exactly how much they should be holding in or out. To resolve this, we kind of made an intermediate ground where we meshed both static and dynamic hand poses to accommodate this. What I mean by that is the hand would work free-forming until it got to the object. Then at that point, it would lock to a more static pose that would look natural to how you're supposed to hold it. So in this case, the cup would always appear like the hand is holding it nicely. But we would have a little bit of leverage on either way. So even if you were holding it really tight or had a much looser grip, it would still hold it until it was needed to drop. That way, it allowed for a lot of usability concerns to kind of be removed. In some cases, though, even by having this kind of mix between static and dynamic poses, it didn't quite make sense due to the interaction itself. And one great example of this was this lever I'm talking about. On this lever, if you think about how you can interact with it, there's literally millions and millions of different ways you can grab it. You could grab it from the edge, you can grab it from either side with either hand, different points along it. And it became very complex to build a system that would just adapt no matter where it is and still provide these trade-offs to allow for kind of a looser grip if needed. Because of that, we edged on the size of usability because ultimately people need to complete the task in hand. And even if it's one or two spots, that's a little bit less so, it's still really impactful if they can do it. So in this case, the hand itself, as you can see, deforms completely through that virtual object, allowing it to be grabbed however you want for maximum usability. So I'm now actually going to show what this looks like when you put it all together. So again, you're dropped in a virtual barista environment. And here you can see all kinds of buttons in front of you, stuff like that. And you're guided just with little kind of pop-ups to tell you what to do. Grab the cup, grab the label, put the label on the cup in a second. And again, I'm not telling someone how to do any of these steps. It's just placing it and following the instructions based on how they would in the real world. And if your experience is built correctly, everything should just kind of work, right? Here they're pushing the buttons. As I said, this was all adapted off of real training material that was provided to us. So really step by step, including things that might be a little mundane in most tasks. Here we kind of have them port. Again, this is that complex gesture I was talking about, but because we have the physical nature to it, all of a sudden it looks very intuitive. Here you drop it here. Now we're going to teach all kinds of different things. We're going to show you how to use this lever here, and we're going to go into the full cleaning process of this because we want it to be as realistic as possible. We're going to pick it up, put it down, play with other things. Now you'll notice as you interact with different elements in the scene, your hand will deform naturally to some and not the others. Like I said, that lever, for example, your hand was able to go through, but the sponge was in a static position where it looked always natural to hold. Here you clean out the lever yet again. And then on your final step to becoming a certified barista here, you grab your coffee, you grab your milk, and you make yourself a latte by pouring it in. And lo and behold, you've now completed your coffee training. And what's great is now this is something you can do infinite times from the comfort of your own home without the judgment of others until you feel like you've gotten it right and you're ready to actually do it in the real world. All right, so I will briefly pause there and take any questions on that one before jumping to the next.
We have one question in the chat from my colleague David. He asked, how would you use natural user interfaces to teach something that requires dexterity? The challenge of how to foam milk to make latte art.
Yep. So dexterity is definitely something that is becoming much more usable with technology as it becomes better. So if this was, 6 years ago, I would say there is no way with hand tracking technology. Nowadays, it's robust enough that you probably could do something like this. The thing is to really account for the limitations of the technology itself. So for example, if you know that making certain gestures, for example, might cause the system to not track perfectly fine, or if you're doing something like obscuring your hand behind another hand, that it might reduce its accuracy, build the interaction to try to avoid those as much as possible. I'm not an expert in how to make a latte art myself, but I would assume you're pouring in a specific way and using the spoon to move it around. In that case, it should be things where as long as you kind of have the proper traction on things, you do it. I will note that kind of going back to what I was mentioning earlier about adding additional tools into the scenes. If you're doing something with, an additional tool at hand, like let's say a spoon, for example, incorporate that into the actual product itself. Take a little spoon, maybe pop a fiducial on it, do some tracking, and then incorporate that in part of the rest of your interface to really make it feel as natural as possible and train them as best as you can. I think some more questions look like.
Yeah, Tomi has a question. Thank you for sharing this. I think this is a big issue in building for XR, hands passing through objects you interact with. In your projects, how do you navigate that aspect?
Yes. So there is a whole area of research in the XR industry called what I would say physical hands. And it is something that is still ongoing to this day, I will say. There's, various different companies that are trying to approach this. Ultraleap has had its own approaches that you can find in its plugin. There are companies that do things like Hand Physics Labs, which deal with that. So it's something that more and more work is continuously being done on. And the idea is that ultimately you don't want your hand to pass through objects, but like I said, it becomes a balance of the usability because you don't have the haptic feedback to know exactly what you're doing. So I've seen a lot of scenarios where you have these kind of physics hands-based interactions where you pick up something and you try to manipulate it, but because you don't exactly understand how tight of a grip you have on it, things will drop, things won't throw exactly how you expect it. It'll feel a little sticky maybe. So it's something that's really kind of ongoing to this day. I will say that there are some other projects that I've worked on, which I don't have videos right here, but you can find on my website, which will show interactions with like physical objects with an airplane, for example. And it can be really, really useful depending on how it's anchored. Often when I find if it's like something fixed in position and you're grabbing it back and forth, it's really great to use with physics. But if it's kind of free form in the air, then you can run into some of those issues. Okay.
We also have a couple of questions about accessibility, I think. So my colleague Carly asked, I'm curious if this is adaptable to people with various mobility challenges. And then our student Nandita asked how you track hands and model hands with missing digits.
Yep. So kind of answering both those at the same time. On the missing digits front, a lot of these tracking softwares will actually just provide the missing digit as best as it can. So depending on how much of the digit is missing, if you're missing like half of it, it might still be able to do some motion while obviously the top part of it might be locked out. Whereas if you're missing a digit altogether, it'll usually just kind of infer from the other digits next to it. So for example, let's say I'm missing this finger, right? If I'm moving it down with the other two, the model will often assume that those moving in parallel, just based on the way the human hand works and how most muscles will move together along with each other. On the mobility issue and kind of how to accommodate this in software, the ways to do it is to really account for as many possible different interactions as possible. So often I've seen systems where you need to do very, very specific actions. So let's say if I pinch, I really can only do it if I'm using these two fingers, for example, or only these two fingers. If you do that, then you're going to run into issues where if someone does have a mobility issue, let's say, they have arthritis in their hand, they can't move specifically these joints, it's not going to work. So accommodating as much as possible, allowing for different gestures, maybe a grab or a pinch, whatever's more comfortable to them. This is also kind of going back to moving away from gestures. If you're doing very gestural based things, like, if you're asking someone to do that HoloLens balloon gesture and they have mobility issues, that's exactly the kind of problems you're going to run into. They'll house accessibility come first and foremost. Whereas if you make things much more freeform, then hopefully it works no matter how you're kind of approaching it.
Okay, and then maybe this last question before we let you show us your other project.
Yep.
Nathalie, my colleague, asked, how about the fatigue of holding your hands up front or training where instruments are necessary, like surgery?
Yes.
Have you looked into that?
Yeah. Okay. So kind of taking each one of those separately. So fatigue is actually a big one. And the biggest way to think about that is making things, making the interactions work in the way the human body does. So often I will see people have these interactions up here above your head. And if you do that, you're going to get what we call gorilla arms, and your arms are going to get really tired because you're holding it like this all day. The body isn't built to do something like that. But if you have your hands in a much more relaxed position, so I think a really great example of this is like the Apple Vision Pro, where they do these kind of subtle interactions from a relaxed position, where you can like rest your hand on your leg and do something. Being able to do something like that will allow you to have a lot more comfort in these long experiences, so you don't really have to worry about the fatigue. On the surgery side of things, it's pretty interesting. Hand tracking technology actually has been deployed into the medical room, but usually not for the surgery itself. It's more for the sterilized aspect of it. If you think of the way, operating rooms work, the person operating is not able to actually, press any of the things because it would contaminate stuff. So what happens with it is they often use it just for kind of interfacing with the world around them. So maybe, swiping between panels of an X-ray, or like being able to manipulate something so they can see it in space, rather than, assisting with the surgery itself. As the technology progresses, I could definitely see the surgery side of things getting better. But I think in terms of the precision level and stuff like that, it would definitely be a risk to not have all the senses really doing it. So for surgical kind of VR scenarios, they often use much more complex tools which have physicality to it. So like, a pin you would move around and do something like that. Okay. All right. We'll hold the next questions until after the next part, but I'm going to jump into one final example of natural user interface in action, which is this project I worked on actually this last year called Vista, and it's showcasing VR, hand tracking, and eye tracking. So again, just to set the stage, this was early 2023 when companies like Meta and Apple were starting to showcase their products. So like the Apple Vision Pro, for example, was just getting showcased in their trailer. And they were showcasing how natural user interfaces are the frontmost part of their whole experience, how there's no controllers and you do everything with hands and eyes and stuff like that. Now, at this time, I've been working with a lot of companies that didn't have access to the proprietary technologies of people like Meta and Apple, but all these third-party solutions existed. There was companies like Tobii, there was companies like Ultraleap that were able to do all this at the same level, if not better in most cases, than what was being showcased by people like Meta and Apple. So I went to the head of product and the head of marketing, and I started a plan to kick off a project working towards CES of this last year, 2024, to showcase these third-party solutions in action. Now, the problem is that what we really wanted to showcase was something that was beyond the APIs that most of these things provided, which what I would call complex gesture recognition, gestures that involve motion along with, kind of action of the hand itself. So kind of back to the drawing board first of how to think about approaching this kind of project. The first step was to prototype, and then do even more prototyping. And so this is an example of something that actually didn't make it to the final cut, but in any of these projects, when you're starting to play with new technologies, you really need to experiment with them and see what they're capable of doing. You might read something on paper and saying, this is the best solution in the world, this can do this, that, and the other thing. Once you actually start playing with the technology, though, you can find limitations to it pretty easily. Or maybe things that, they didn't highlight themselves. In this case, this was the idea of like, having a map you can open up to interact with different rooms in your house. It was a pretty cool idea, but it was something we ultimately didn't go with because we wanted to make it kind of a more contained trade show experience. So on that note, what eventually happened was I sat down with the designers on my team and we talked about working with the limitations of the hardware. And what I mean by that is if you think of your typical headset, let's say it has about a 90-degree field of view, and hand tracking can work within this range and eye tracking can work within this range. Is there a way we can actually use this limited range to guide someone through an interaction? And we came up with this idea where no matter where you looked in a room, you'd be able to see another interaction, hopefully through your peripherals, to guide you through whatever next step you're supposed to be doing. So the final design, which I'll show in a bit, is you place someone in the center of a room. There was 3 or 4 interactive panels in front of them. And as you looked at one, you would not only see what you're currently interacting with, but hints at the other things that you should be playing with in that space. The other thing I also kind of want to mention here was this complex gesture recognition problem. So like I mentioned, a lot of the APIs really detected only a single frame pose. And what I mean by that is it detected like a pinch or not pinch, a grab or not grab, looking at a specific point or not looking at that point. And we really wanted to go above and beyond that. We also wanted a way to avoid false positives in this case. We didn't want someone to pinch and just all of a sudden trigger 100 things by looking around the room. And more importantly, we also needed to support future undesigned gestures. Now, in this space, since it is relatively new, it's not like there's a little book I can look up and say, this is the gesture I should use for this particular use case. I really have to be free form in how I work with this. So, there might be things that I don't even know we need the gesture for that I need to design going forward. So let me break down a little bit of how to approach something like this. First, like I said, the APIs were providing something like a pinch or not pinch. Next, we were able to get motion from the game engines we were using. So for example, Unity in this case, if I take 2 points in space, I can take the difference of them and get a direction vector. And if I combine this, static pose of a pinch plus direction vector, then all of a sudden I can have something to intuitively interact with the thing in front of me. So here, for example, I'm scrolling up and down. So again, looking at that a little bit more detail, if I look along the x-axis, so horizontally, right? If I make a pinch and I move to the left and right, and I lock my up axis and my forward axis, then all of a sudden, no matter what I do in this space, I'm controlling the way I want it to. I can move my hand in and out as I do this, but as long as I'm moving left to right in the general trajectory, that's all that matters to really get it working. Likewise, if I flip it to locking out the horizontal axis and the forward axis and only looking at the Y or the vertical axis, as I move my hand up and down, all of a sudden I'm controlling this lampshade no matter how I'm moving in space. And kind of treating this as Lego blocks to kind of discover other gestures at the same time, I can take the combination of these two, looking at both the horizontal and the vertical, combine them together to do like a color picker, for example, where I can move around anywhere in the space to be able to select something with a freeform nature. Okay, so let's look at what this ended up being in action. So this was done in combination with Toby. So there's a little bit of eye tracking to begin with. We do an in-app calibration, so they never have to leave the experience whatsoever. Looking at a few dots. And then we try to teach them very early on the interaction we want, looking at something and making a pinch, right? So they go through that. They're greeted with a virtual world where hopefully everywhere they look, they can see different interactions around them. There's little iconography to show them what to do. In this case, you can look up and down, do that same gesture to be able to use a reader. And then in a second, they can go back and use a similar gesture on a different axis, horizontal in this case, to scrub a video back and forth. Finally, they are going to jump into one final spot here, where they are going to look at a color picker over here. And then also just to show that the technology was capable of going above and beyond, we added a bit of physical interactivity in the end with a little Easter egg where when they look at the sign, it'll come to them. They can have a turntable in front of them that they can physically play with. And then because this was presented in Vegas, we added a little bit of Vegas flair, putting it on the top and having some fireworks go off. And that was just kind of the combined interaction. All right, so on that, I will open the floor to general questions and answers. And thank you all for your time. If you want to see more, you can go to my website, lazloring.github.io. If you want to see more on XR guidelines, you can go to Ultraleap's documentation. And if you need to contact me, you can always hit me up on LinkedIn. So I'll open up to questions now.
Thank you. So interesting. I love seeing that the little fireworks flare at the end too. Fun. I know, Namrata, do you want to come off mute and ask your question?
Yeah, sure. Hi, I'm Namrata, and I had a question regarding, you mentioned that there are some cultural differences which pose certain questions and situations, and there was some discussion about mobility issues. So do you think what are some troubleshooting regarding that? Do you suggest we give out like a survey form in order to customize these experiences, or have you had any experiences like that?
Yep. So I think two sides to it, I guess. One is if you have a survey and if you know the demographic that you're targeting, then that will definitely help in the long run, because then you can accommodate for, if you, for example, are doing an XR experience targeted to older adults, and you know that they might have less mobility in their hands, to build around and accommodate that. The other side of it is just really to have as much options as possible to do it within the experience itself. So if there's different ways you can do it to accommodate for different levels of mobility, Often an example of this is like we'd have the ability to pinch a block and grab it up and move it like that, but also to just physically move it with your hand from side to side. So that way, if you had less dexterity within your fingers, you can kind of just use a full paddle motion to do whatever interaction you need to do there.
Thank you.
Yep.
Okay, we had another question from Amir. I'll just go ahead and read it.
Sure.
He said, thanks for the informative presentation. And then when designing natural user interfaces for multi-user applications, what key considerations and challenges should we address to enhance collaboration without overwhelming users, especially those who are new to XR?
Okay, so multiplayer applications in VR are a whole set of worms that are really, really cool to do, but they introduce a ton of issues. That being said, the real main ones that you have to look at is different depending on the devices themselves. So the first thing, which we've done in a lot of these interactions, is add a social element to it. So in that Crystal Cave project that I was talking about earlier, which was that 2-player VR experience, just having person's hands available and seen by the other person alone can add a whole level of interactivity that like you don't even need a script into your interaction. We had people get into it and do high fives and rock, paper, scissors with each other without having to build anything in the system, just because naturally, if they see their hands and see this kind of interesting experience in front of them, they'll adapt and do stuff. That being said, you really need to make concerns about latency. You want to be sure that, however you're transferring stuff over the network, that it's working in a way so you're not adding additional latency because you don't want people to bump into each other in this multi-user space. Additionally, you also need to think about how to understand which parts of, which interface is going to which user. So for example, if I have hand tracking systems on 2 sets of headsets and they're both next to each other, you need to make sure that you're getting the right person doing the right interaction or separate the experience out to kind of avoid that naturally.
Thanks, Karmisha.
Hey, thank you again for that awesome presentation. You said a couple of times that with your sample projects that people who were doing the experience didn't need any external guidance. And I was wondering if you had any background information on those people. Was this experience that you put them through their first time accessing XR VR, or had they at least had a headset on before?
It was full gamut of both sides. We had people who literally this was their first XR experience, all the way to people who've done XR for years and years and years. And really just, the kind of sign of a good XR experience to me is like if you put someone in there and you don't have to teach them anything ahead of time, you've really nailed it out of the park at that point. And by relying on the innate knowledge of the world, you really can bypass a lot of that stuff. So at these trade shows, some of them were not XR focused. I mean, CES is just a generic technology trade show. And there was years where we weren't even in an XR section. People literally came in for their first XR experience ever and were able to just do it without any guidance. Likewise, we did things at like theme parks, at college campuses, whatever it may be, to really allow the gamut of users to go through it and, have it as their first try.
Okay, that's awesome. Thank you.
And we have a question from Natalie that natural user interfaces have been around for many years or decades now. What would you say is the biggest leap that's been achieved, and what are the challenges that are left?
Yep. So I think the general quality of them has definitely increased by a significant amount over the years. If I were to look at, hand tracking systems from 4 or 5 years ago to today, there's a huge difference in robustness for just basic things you can do, which will kind of lead into some of those biggest challenges left. I would say occlusion is still one that, while it's gotten infinitely better, is still a kind of lingering question here. So what I mean by that is if I'm tracking my hands and I put one hand in front of the other, the vision system obviously can't see the hand that's being occluded, which means what should it do, right? Should you have the hand, drop out completely? Is there some way that you can use an additional sensor to kind of detect what it's going at? All kinds of different kind of areas of that. Likewise, like I mentioned, locomotion is something that really I haven't seen a good solution to with natural user interfaces. Controllers and the joysticks are still kind of the gold standard for all of these kind of things. So while I've seen weird ones where like you grab yourself to move yourself, like almost pulling yourself through space, or looking at a spot and pinching to teleport to it, pulling something off and teleporting with it, whatever it may be, none of them really have kind of like a solid answer that works for all. So I think that's really big challenge. And then the final one, which is also another area of kind of active research, is this idea of multi-sensor fusion stuff. So using multiple of the same devices at the same time, for example. I've seen some really amazing academic research where people have used multiple like hand tracking controllers together to create really good tracking volumes, and then incorporating other things into it like connects and stuff like that. So you really get a fully immersive experience no matter where you are.
So I know we still have some questions rolling in. I know we're at 1 o'clock. So if people need to hop off and if Lazlo needs to go, but
I can stick along for a little longer.
okay, I won't close the Zoom just yet, but I do want to just while everyone is still here, thank everyone for coming to our inaugural XR speaker series. And I want to absolutely thank Lazlo for spending his time and sharing expertise. It's been lovely to hear your perspective and definitely a lot of food for thought for me. And I really want to thank Monica Storss, who's been a huge help organizing and promoting this talk, and my colleagues who also have been working on this speaker series, Nathalie, Sean, and Mirjana. So thank you all. And I did put a couple links in the chat, Lazlo's contact info on LinkedIn, but then also here at Northeastern, we have 2 programs in XR. So if you or someone you know might be interested, please check them out. A master's in extended reality and a bachelor's in performance and XR. So check them out and feel free to reach out if you have questions. But otherwise, let's go. I think Wallace and his students have a question.
Sure.
We have a few more minutes. Okay.
Yeah, go for it.
Hey,
Hey.
thanks so much for the time. Really,
Yeah.
really excellent talk. I think everyone will leave like inspired by the things that you built. Really, really cool stuff. So just thinking about them, right? We have like all the students that, in a few years we're going out to the market and hopefully trying to get positions working in like research and developing in XR. So reflecting upon like your trajectory and what you see of the market now, which kind of advice would you give to them? Which kind of skills do you think would be more valuable, maybe 4 years from now?
Yep. So kind of biased opinion, I'll say natural user interface related work is definitely going to be kind of first and foremost. Nearly every company out there has transitioned to having hand tracking and eye tracking as a core feature of their product, and has built, the majority of their technology around it. But I think taking a step further than that, the other thing to think about is the other aspects that go around with that experience. So incorporating kind of the world as a whole, so mixed reality things, augmented reality things, as you see things like the Meta Ray-Bans becoming more and more popular and Meta doing stuff like Orion. A lot of the work that they really care about is how it interfaces with the world around them. And so really incorporating that into their thought process of how to make it beyond just being a headset only experience and interacting with everything they see around them.
So thank you so much again.
Thanks. And I actually think so. Comey has a question about the Orion wristband, what your thoughts are. How do you think it is, whether it's good or bad in terms of natural user interface? And then Namrata's question is a little similar, actually, whether you've experimented with wearable tech to solve the problem of going out of the field of view.
Yep. So funny little story about wearable tech, and this is my little bias towards it. Actually, all the way back in Northeastern University when I was doing my PhD, a company called Myo had reached out to me and gave me a Myo wristband to try. And that was my first experience with wearable tech. And we tried it for the good course of a week, and literally 0 people in our office were able to successfully use it the way it was supposed to be used. So that's my first kind of thought that I think of when I think of wearable tech. Now, obviously, things have gotten better since this point. But I do think that the problem with wearable tech is it's wearable, which means that you have the setup time to get it on and off. There is some really cool companies out there that can do amazing stuff with wearable tech. So like haptX is one of the first ones that comes to mind. So they have like these giant systems where you put your arms in these big tubes and you can really like feel absolute pushback when you touch stuff. But the problem is it's this whole setup process of actually getting in and using it. That being said, like I haven't tried the Orion wristband, so I don't know how good or bad they are. I do think it's kind of a supplement to just something that can be solved by the technology on itself. In hand tracking, for example, you could just add more cameras and that would solve most of these issues. So instead of having to worry about wearing a wristband, if you literally put like cameras to the side. So right now, a lot of the geometry that these products do are based on kind of boilerplate reference designs from companies like Qualcomm. If you look at like the Quest versus any other headset out there, they are nearly identical in terms of what they have in their hardware. So literally just kind of expanding that and making more to it sounds like a better solution to me than investing in things like wristbands. But again, I haven't tried them, so maybe they're fabulous.
I don't know. Yeah, Masa is still here. She asked how you envision incorporating eye tracking beyond the mentioned gaze-based interactions. Any thoughts on that?
So I think eye tracking is really, really powerful as long as you accompany it with another form of input. So like I said, eye tracking itself, like, Tobii has some really, really cool experiences. For example, if you go to their site, play with their technology, where you can look at specific things, you can have something highlight and get to you. It's a really great way to interact the world around you. But if you don't have something else to kind of actually do that interaction, it becomes a really slow way to do things. So if I look at something and I could maybe do a gesture to bring it forward to me, if I could, push it back and it goes exactly the spot that I want, beyond just being able to throw and play games with it, stuff like that, it allows you to have this really infinite space that you can bring to your fingertips and do really precise things. So it's this great combination together. So I can imagine desktop computing, for example, where you have a million windows in front of you and you look at a very specific one that you want and then pinch and bring it forward, do some work, throw it back. And then that way you don't have to worry about doing weird things where you're aiming with your hand to get a very specific spot or doing something weird like that. Just kind of using their strengths to each other.
All right. Well, thank you so much, Lazlo,
Yeah.
for joining us. And thanks to everyone who's here as well and for all of your great questions. And yeah, we look forward to seeing you at the next speaker series.
Yep. All right. Thanks, everyone.
Bye.
Thank you so much.